Morning, students. I saw what the lesson plans were about today, and I decided to do a video real quick. Um, shouldn't be anything groundbreaking, but it is something that we haven't done before, which is science math, is what I call it, or sciencey math. You got your mathy math that you might do in your other classes, but this is science math, so it's a little bit different and it has different requirements. In a regular math class, you can just have a number, like a number 2, and it doesn't mean anything. It's just 2. But now that we're in chemistry, or if you ever choose to take physics, a 2 has to mean something. So it could be, I don't know, 2 grams. It could be 2 degrees Celsius, but it does have some physical meaning. And so what we're going to look at today, just kind of quickly, is the heat math practice, which you'll see on the lesson plans for today. Today's April 30th. Hopefully you did the bell work. It's not too confusing. Hopefully you wrote the notes. And remember, when you guys are copying down notes, do not just copy them down as quickly as you can while watching a TV show in the background or while pausing to Snapchat or whatever it is you kids are doing. Focus on what you are doing, okay, and think about what you're writing down. Otherwise, you're just copying, and that's a waste of your time. So let's take a look. So this is again just the lesson plans for the day. And again, if you haven't been looking on here, I don't know what to tell you. You know that everything that we do is on OneNote. I'm just doing Google Classroom because I was told I had to by Buncombe County. So you can look on Google Classroom, but most of everything is going to be right here in OneNote. I want that to go away. Don't know? Yeah. So anyway, here's your bell work. You should do that. There's the notes. You know where to find them. And if not, I mean, it's in whatever class you're in. Okay, if you're in my 4th period, for instance, you go to the NARIN folder. You go to Unit 6. What do you know? Here we go. Calorimetric calculations notes. There they are in all their glory. So not real complicated. But what I want to focus on are these heat math practice problems. And again, it's with 5 steps. And what are the 5 steps? Well, if you took the notes, you should know what they are. But I'll tell you what they are real quick. I'll tell you what they are. So 5 steps. Excuse me. Step number 1. Okay. Write what you know. This is really important. And you may be saying, well, missionary, that seems like a waste of time because why would I write what I know if the problem tells me it already? The reason you write what you know is you write it with variables, you write it with the letters. So, for instance, speed. Instead of writing the word speed over and over and over and over again, it'd be a lot easier if we could just say, oh, well, S is equal to 10 miles per hour. Okay? Much easier. And so that S is what we call a variable. The 10 is just, I don't know, a value. And then the miles per hour is what we call a unit. So please know the difference. I'm going to use those words a lot, okay? Variable and unit. But the variable, the root of that word being vary, okay, is going to vary from problem to problem. So we're dealing with heat right now, okay? We're spending a lot of time talking about heat and heat energy and mass and all that types of things. But it's called a variable because it's going to change. So the mass in problem number 1, I can see over here in the corner, 360 grams. So in one problem, it might be 360, and the next problem, it's going to be 24. It varies, so that's why we call it a variable. And instead of writing mass over and over and over and over again, we just say lowercase m. That's a lot easier. Step number 2. Write what you don't know is what I've had a lot of students say, but I say write what you are looking for. Okay, write what you're looking for. And again, you may say, well, that's dumb. If the problem says it, why would I do that? Again, the reason you write what you're looking for, I'm going to show you in a second, is it helps you pick what equation you want, which leads us to step number 3. Step number 3, write out the equation. And this is really important. Write out the equation with letters only. Okay, write out the equation with letters only. And the reason we do that is we're trying to see, okay, I've got here, this is just an easy one. S equals D over T. Okay. Speed equals distance over time. That's a physics equation, but I was a physics teacher before I taught chemistry. So we have S equals D over T. So we're writing just letters first. And the reason we do this is so we can go through and check and be like, well, the problem gave us speed. so I know speed. Maybe the problem gave us time, so I know time. And then you say, oh, well, I'm looking for distance. That's what I don't know. And so this is a really easy way to make sure, are you using the equation that you should be using? And this is how you do it. You just say, well, if speed equals distance over time, distance is what I'm looking for. That's where that question mark is there. And so look, if you've got everything that you need, except the one thing you're looking for, then yeah, you can do it. So write out the equation with letters only. Next, step number 4, okay? Fill it in. Sorry, I'm not going to say it. Fill in the equation with with numbers and units. Units, very important. Right now we're just doing calorimetry problems, which means we'll be using like the same 3 equations over and over and over again. In fact, we use one equation a lot more than the other ones. But pretty soon we're going to be doing something called ideal gas law. And when you do ideal gas law, all your units have to be the same. And so it's important that you write the units out so you can make sure, this is measured in Kelvin. This needs to be measured in Kelvin too. And so just trust me, write units. And another reason I tell you that is that if you guys ever just put a number, like maybe you say 32, I don't know, 32, and that's all you tell me on a piece of paper, then I'm going to probably say 32 what? I don't know, because you didn't tell me. 32 watermelons? There's no way to know because you didn't give me the unit like you should. So always make sure that you write the unit. That's very important. Okay, now it's loading, of course. All right, so if it's not watermelons, then you tell me, no, this is 32 grams. All right, let's move on to step number 5. Step number 5 is write answer with units, okay? Still need to have units on your final answer, and box it. Put a box around it, which is something that we've been doing since the stoichiometry problems. It's just that half of you are not doing it. It's really important that you box it because as you're going through this, especially these problems, you got 5 steps. But I need to be able to quickly be able to find your answer and be like, yes, they got the right answer. And then I can look and say, all right, did they do the first step? Did they write what they know? Did they write what they're looking for? Okay, did they write the equation? Like, then I can check everything, but you got to box your final answer. Okay. And I've had students in the past who'd be like, well, can I circle my answer? Sure, I don't care. If you want to circle it, that's fine. But if it's your final answer, you need to indicate it somehow. And then, of course, you've always got that one kid that's like, can I triangle my final answer? Sure. Just, gosh, don't. You know who that kid is. All right, let's take a look at these problems now that you know what my expectations are. So here we go. Let me check to make sure everything's running the way it should. I'm sharing screen. Apparently, there's one person on here. All right, here we go. Problem number 1, or problem number A. It says, how much heat is required to melt 360 grams of solid water? I guess now is a good time to show you that we really only got 3 equations. We really only have 3 equations that we'll be using over and over and over again. And they always use Q. So one of them, the main one, I call it, is Q equals M, okay, C. And I think it actually says, yeah, it says CP on your equation sheet. I've never really done that. Delta T. So I've always called it the MCAT equation because it looks like it says MCAT, even though it's really a delta. This delta symbol, I'll go ahead and tell you really quick. Hopefully you've looked in the notes, but that means change in. So specifically what we're looking at here is if it says delta T, we're looking at change in temperature. Okay, change in temperature. So for instance here, delta T actually means TF minus TI. So TF just means T final. TI means T initial. So it's always going to be your final temperature minus your initial temperature. And hopefully that'll load here in a second. I don't know. My internet's been really slow today. All right, moving on. Another equation that you may see, there's 2 of them. Go ahead and write them up here as well. Still using Q is going to be MHV, which is the heat of vaporization. And then we're also going to have Q equals MHF, which is the heat of fusion, okay? And again, if you've taken the notes, you'll already know that. And hopefully it'll load here in a second. I don't know if we can minimize any Wi-Fi use or anything, but it's being really slow again. And I'm doing the notebook that I should be using. I went ahead and got it started because everybody was quiet. All right, so anyway, it'll load here in a second. All right, let's try this and see what happens. So problem A, how much heat is required? So let's go ahead and start by saying, okay, let me get this because this is going to bug me a lot. Please do it. Show me what I'm looking for. I've already written it on my device. And you know, guys, I really thought I had dealt with these issues, but apparently not. But then again, my Wi-Fi has been really, really slow this morning, and I don't know what the issue is. Well, I'm just going to keep on pressing and hope that it'll show up here in a second. All right, problem number one, step number one. And I'm going to write out the steps for these first couple of problems, just like I'm going to at least number them. You, of course, don't have to do that. But if it helps you keep track and make sure you're doing everything, then great, do it. Because that's my expectation. I wrote 5 steps here for a reason. You should be showing your 5 steps. Alrighty. It is not loading anything, so give me 1 second to see if I can figure out what's going on. I've got a good connection. Tells me I have an excellent connection on the YouTube. So yeah, it's just OneNote being OneNote. Let's close that. Let's close that. Let's close that. Sure, I'll save. All right. This is still great. I'm gonna reopen it. There we go. All right, we're in business. Number one. So step number one, I can look at my list and it says write what you know. So let's see, what is this problem actually giving us? Well, it says 360 grams of solid water. Wow, that's so useful. They gave us one piece of information. So I'm going to go and write it down. Okay, I'm going to start. Well, mass equals 360 grams. And if you're saying, well, Mr. Aaron, how'd you know it was mass? Because I know that mass is measured in grams. It does not have to tell me, okay, you have a mass of 360 grams. They don't need to hold my hand. I know that grams is a unit of mass. And it also tells me that it's water, which is going to be really important here in a second, because that also gives us one other thing. And that also gives us one other thing. So we're melting, all right, solid water. So melting, I don't know if you guys remember, but melting is also called fusion. And so they're also giving us the heat of fusion. Okay, so I'm looking at my not green sheet. Okay, I've got my equation sheet here, which again, you have as well. So I already know what equation I'm using, but I need HF. So I'll look on here. It's got to be on here somewhere. There it is. So I'm on the front page of the green sheet, and it says HF for water, and they did tell me water, that's something they gave me, is 334 joules per gram. Whoa, that's actually right in this. So even though they didn't write that number in the problem, I still know it. I still have it. And so that is very useful. Does that give me anything else? No, it does not, which leads to the next part of the problem. So step number 2 is write what you're looking for. Well, what am I looking for? It says right here, how much heat? How much heat? And that's always going to be represented with a Q. Q, I know you guys are annoyed because you're like, well, wouldn't they just make it H for heat? It's because Q, I think, really stands for quantity of heat. So how much heat is quantity of heat. So we know we're looking for Q equals, and then I always recommend you write Q equals question mark. And so now right away, I can see, oh, look, I've got mass, I've got heat of fusion, I have quantity of heat is what I'm looking for. So what equation has all these things? Well, I can see it's right here. There's the equation that I want. So step number 3, write out the equation in letters only. And I don't care if you're sitting there at home going, oh, that's so stupid, it's right there, why would I need to rewrite it? Well, the reason we rewrite it is so that A, if it's not written the way I want, I can rearrange it. In this case, Q is what I'm looking for. Q is already by itself on the left side of the equal sign, so I don't have to do any algebra here, but if I did, I'd need to rearrange it. Another reason we do it is that for step 4, which I'm going to do step 4 right underneath it, I'm just going to plug in all the information right where it needs to go. And so it's like it sets it up. So now I'm going to say Q. Do I know Q? No, I don't. So I'm just going to rewrite it because I know that's what I'm looking for. M. Do I know M? Yes, it's 360 grams. Do not forget your units here. All right. I wrote grams over there on the left side. I'm going to write grams right here. HF. I'm going to put that in. 334 joules per gram. That's important. I'm putting the units with it. Okay, so everything has a place, and then because I wrote it in step 3 and I wrote it out in letters, I know exactly where everything needs to go. The biggest issue that I have, okay, with students, the biggest issue I have with students is when they're doing these types of problems, they'll just look at it and they won't have written anything down, and they'll just be like, well, it gives me 2 numbers. I guess I'll just multiply them. And then they do. And then they get the wrong answer, and they're like, I don't get it. I don't know what I got. I'm telling you that by using these steps, it tells you exactly where everything needs to go. So there's no second guessing and saying, oh, do I multiply? Do I divide? I know that I'm going to multiply because I filled it in. Step number 5. Okay, I've got my calculator here. 360 times 334. And I get a huge number, which honestly makes sense. Joules are actually a pretty small unit of energy. That's why we usually will measure car energy in horsepower. That's why we measure our food energy in calories. Joules are pretty small. So I'm getting a really big number, and that makes sense to me. So I get 120,240. Okay, and again, if you stopped right there, I would be upset with you because what did we forget? We forgot the units. Okay, you can't forget the units. So what units is it going to have? We got that blank right there. We need to figure out. So if I look back above, I had grams on the left side, okay, 360 grams times 334 joules per gram. So literally what I'm looking for, or what I'm looking at right here on this step, is I have grams times joules over grams. And so what's going to happen to grams? Well, it gets canceled out. And so what I'm left with is joules. So I'll show you that again up here. Grams goes away. I'm left with joules. So my answer is going to have units of joules. And what do we do with it? We box it. Always box your final answer. So the way that it sits right now, I'll erase this because you don't need to do that every time. But the way it sits right now, that is my expectation, y'all. So if you're sitting at home and saying, well, that's dumb, why wouldn't I just write the 120,000? Because that's not what I'm looking for. As your teacher, I am telling you, I want to see all 5 steps whenever you're doing one of the problems like this. That is your way of making sure you know what you're doing and make sure you use the correct, multiplication, division, you use the correct operation. That's what I was thinking of. And it keeps you honest. Because whenever I see a student where all they write is 120,000, I'm going to say, oh, well, they just copied it off somebody. Oh, they just got that answer from somebody. But this way I know at least you're doing the work. B, how much heat is required to vaporize 24 grams of liquid water? Well, I wonder what I'm going to do here. It sounds very similar to the last problem. The only difference between this one and the last one is instead of heat of fusion, now I'm dealing with heat of vaporization. So more than likely, this is the equation that I'm going to use. Q equals mHV. But again, we got to go in order. So step number 1. For those of you that don't see where we're going, that's why you do the steps, because then you'll be like, oh, that's why I use that equation. So let's see here. Let's see what it gives us. It says how much heat, all right, so I already know what I'm looking for. I'm not going to write it down yet, is required to vaporize. We're going to vaporize 24 grams of what? Of water. So once again, that's a big hint. That gives us some information. Even though it's not in there, it still gives us some information. All right, so step number 1, we're writing what we know. Well, I already know mass is 24 grams. That's really easy. Mass equals 24 grams. And because it says the word vaporize, and because it says the word water, I know that I have heat of vaporization of water. So once again, on my chemistry reference tables, it is right here, HV, for water, which is great, because that just happens to be what we're dealing with. It's almost like I wrote it with that in mind. So HV is right here, and it's 2,260. I don't know why I'm holding it up. You guys can't see it. So 2,260 joules per gram. is going to be my heat of vaporization for water. Does the problem give me anything else? No, it does not. So let's go to step number 2. Remember, step number 2, what are we looking for? Well, how much heat? It says how much heat. Remember, heat is represented with a Q, which means quantity. So we're looking for quantity of heat, just like before. So you may be thinking, well, then I'm using the same equation. Not quite, because instead of HF, now we have HV. So it is a little bit different, but it's very similar. So I'll go ahead and write it out. So Q equals MHV, H subscript V. I have some students that have difficulties with subscripts because they'll look at that and be like, so am I doing H times V? No, guys, the V is a part of it. Just like earlier, we did this TF and TI up above. So we had delta T equals TF minus TI. The reason we did that is it's T final, okay? It's a part of it, final temperature, and then TI means initial temperature. It all goes together, so keep it together. Step number 4, I don't need to do anything else in step number 3. Q is what I'm looking for. Q is already isolated by itself, so I don't need to do any algebra, so I'm good to go. So step number 4, I'm going to start plugging and chugging. All right, that's something you've probably heard before, plug and chug. Q, I don't know it, so I'm just going to rewrite it. M, I know is 24 grams, so I'm going to write that. HV is 2,260 joules per gram, so I'm going to write it just like that. And then, boom, there you go. It has everything that I need and what I'm looking for. So we're set up for success. So step number 5, you should just plug everything into your calculator, which I'm going to do really quick. And then we're going to write our answer. And I get 54,000. 54,000. That's a good 4. 240. And once again, okay, if you just stop right there, I'm going to criticize you and I'm going to say, oh, well, why didn't you put units? You've got to put units. And so once again, I look and I can see, look, my grams cancel because I had grams times over grams. And what I'm left with was joules. So it's going to be 54,240 joules. And I am going to box it because that's my final answer. Okay, I am going to box it. It's my final answer. All right. If there are no questions from the one person that's in here, we'll keep going. So let's look at part number C. For a 500-gram block of lead to melt, how much energy is needed? Okay, and they're giving me the heat of fusion of lead, and I'm not sure why I wrote a delta there. It's kind of weird, but whatever. In fact, I'm going to just make that disappear. I have that power. There we go. Do the next problem too, because I don't need it there yet. All right, so anyway, heat of fusion of lead is 23 joules per gram. So same thing as before. Let's write out what we know. 500 grams. Heat of fusion is 23 joules per gram. And we're looking for how much energy. And before you say at home, well, but we've been dealing with heat. We don't know what to do with energy. Guys, heat is energy. It is a type of energy. In fact, it's called thermal energy, and it's because it's just heat. It's just transferring kinetic energy of molecules from one substance to another. But yeah, we don't need to get into that. All right, so let's go ahead and go through our steps. I'm going to go a little more quickly this time. Step number 1, I know that it gives me the mass. This is 500 grams. I know it's giving me HF, which is 23 joules per gram. Okay, that's really helpful. And then now, step 2, because it doesn't give me anything else, it tells me it's lead, but do I care? No. All I need to know is what the heat of fusion is, and it tells me that, 23. So step number 2, I know I'm still looking for Q, quantity of heat, energy. Remember, quantity of heat, energy. So how much energy? We can still find it. Step number 3, the same daggone thing. Q equals MHF. So easy. Step number 4, plug everything in. Q is what I'm looking for. Okay. M is going to be 500 grams, and HF is 23 joules per gram. Step number 5, I'm going to plug and chug and find out what my answer is. It's going to be 500 times 23, and I get 11,000. Oops, I don't want to write red. Q equals 11,500. 500 what? Watermelons? Probably not. It's going to be joules. Okay, and I know that because I can see my grams and my grams cancel. And then I'm going to box it. Take it home with you because restaurants aren't open right now anyway. All right, now let's look at D. All right, mercury is a metal that is liquid at room temperature. In order to solidify 7.5 grams of it, how much energy needs to be removed? Now, this one's a little weird. I mean, it's going to be the same thing. Your sign is going to change though. So instead of getting a positive Q, we can expect to get a negative Q here. And in fact, if we don't get a negative Q, I'm just going to make it negative because it says the word removed in the problem. For more on this, there's a really good diagram in the calorimetric calculations notes at the very bottom. It shows a phase change diagram. And so basically, if you're going one way, you're going to be absorbing energy in order to break those bonds and to speed things up. But if you're going the other way, if you're cooling down, you actually need to remove energy to cool everything off, to slow everything down. So for more on that, hopefully you've already taken the notes if you're watching this, but for more on that, go look in the notes. All right, so let's get started. I'm not even going to write the steps this time. I'm not going to number them. You should know what they are by now. So let's see what they give me. Let's see what they give me. It's a metal, yep, in order to solidify 7.5 grams of it, how much energy needs to be removed? They tell me heat of fusion is 11.3 joules per gram. Wow, that's so helpful. So mass equals 7.5 grams. HF is going to be 11.3 joules per gram. What am I looking for? How much energy? So Q equals question mark. Fantastic. And now I'm going to write my equation. It's still going to be Q equals MHF. Okay, it's still going to be Q equals MHF. And I'm going to plug everything in. Q is what I'm looking for, so I'm just going to rewrite it. And mass is 7.5 grams. And HF is going to be 11.3 joules per gram. Wow, it's almost like we've done the same problem 4 times in a row. Q equals, do some calculating, 7.5 times 11.3. I get it. That's a really small number. Yeah, that makes sense. All right, 84.75. If you're ever not sure about a number you get in the calculator, check everything over one more time. Make sure you're putting the correct numbers where they need to be. Check it again in your calculator and just make sure. And again, at this point, if you left it alone, Mr. Nair would ask you a question, which is what? 84.75 what? So if we look back, grams, I'm left with joules. Boom, there we go. Now, did I use all the steps? Let's see. Step number 1, yep, I wrote everything that I knew. Step number 2, yes, I wrote what I was looking for. Step number 3, I wrote out the equation with letters only. I didn't have to rearrange it because Q is already by itself. Step number 4, I filled everything in with units. And step number 5, I wrote my final answer with units and I boxed it. Let's look at E, because E is actually different. Yay, a different type of problem. I'm just going to leave this here because it's probably going to be useful here in a second. All right, so how many joules of heat are needed to raise the temperature of 10.0 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules per gram degrees Celsius? Whew, gosh, that's a lot of stuff. That's okay because I'm still going to follow the steps. So I know I'm looking for how many joules of heat. Okay, so I'm looking for how much heat. So basically, Q equals what? Are needed to raise the temperature of 10 grams. There's my mass. All right, 10 grams, there's my mass. From 22 degrees to 55 degrees Celsius. Oh no, I have 2 temperatures. I wonder what I'm going to do. Well, I'm probably going to use delta T. And we'll come back to that here in a second. We'll talk about that here in a second. If the specific heat of aluminum is 0.90 joules per gram degrees Celsius, they give me a lot of stuff. So step number 1 is going to take me a minute, but it's okay. Taking the time on step 1 and step 2 to get everything lined up, to write the variables the way that you want them. You know, what is Q? Oh, it's this. What is delta T? Oh, it's this. It is so important. All right, so let's start with the easy one. Mass equals 10.0 grams. Wow, that was helpful. Specific heat, which again, on your equation sheet, they do capital CP. Yeah, so I'll write it the way it is on your equation sheet. Equals 0.90 joules per gram times degrees Celsius. That's really what that means. And then we've got temperatures. We've got two of them. Now think about it this way. We've got these two temperatures. It's going from 22 degrees Celsius to 55 degrees Celsius. So what's my initial temperature? That right there. 22 degrees Celsius is what I start with. It's going from that, it's going to 55. So 55 is going to be T final. Okay, there we go. Now, the reason this is important is I'm going to go ahead and just do this calculation over here on the left side. Technically, another way that you could write that equation, I'll write it up above, is Q equals mCp. And then instead of writing delta T, you could technically write TF minus TI, but then it makes the equation kind of confusing. So I think it's better just to use this equation, the MCAT, and just do the math down here on the side. So delta T equals T final minus T initial. So final is 55 degrees Celsius minus initial 22 degrees Celsius. Now, in case you're confused and you're like, how did you do that? Look, 55, I just told you, is the final temperature because it goes to 55. At the end of the problem, it's 55. So it's the final temperature minus 22. That's initial. We started at 22. It goes from 22. So that's my initial. So that's why. I'll do some quick maths. 55 minus 22 because I can't do it in my head. And I get 33. So there we go. That's going to be really important. Delta T is 33 degrees Celsius. Now, does the problem give me anything else? No. So now we go on to step number 2, which is what are we looking for? It says how many joules, so Q equals question mark, just like we normally do. Alrighty, so let's write out the equation. Okay, let's put it down here so we can fill it in here in a second. Q equals M times CP delta T. So there we go. There's the equation that I want. That is straight from the reference tables. And I just looked and I said, well, I've got an M, a C, a delta T, and a Q. What equation has all 4 of those? Equation sheet says it's this one. That's why you do all this work. All right, so now I just got to plug everything in. I don't need to rearrange it. Q is what I'm looking for, so that's nice. No algebra needed here. I'm just filling stuff in. I guess I could talk out loud, but my throat's getting kind of dry. And I don't want to stop to drink water because you guys complain. Because you're like, Mr. Neal, why do you drink water so loud? All right, there we go. So there you go. I just plugged everything in. Mass was 10 grams. CP was that. Delta T was 33 because we did it over here on the left side and we found it over there. All right, so now I'm going to put some stuff in the calculator to see what I get. So 10 times 0.9, and I could hit enter, okay? Or you can just keep going. Just be careful, guys, especially when we get into ideal gas law. You're going to need to remember your order of operations. And in case you've forgotten what order of operations means, please excuse my dear Aunt Sally, or PEMDAS, or however you learned it. I don't care. But don't forget your order of operations when you're putting stuff in the calculator because I don't want you to get the wrong answer because of that. So I got 297. And at this point, you should be saying, well, 297 what? Okay, remember, you're not just going to leave it alone. Don't leave it naked. So let's see. We had grams here, so grams is going to cancel. See, grams times over grams cancels. And look, we had degrees Celsius, we had degrees Celsius. So what are we left with? Joules. What did the problem want? Joules, because it says it up here at the top. So what do you know? We did everything we were supposed to do. Boom, answer. So, guys, as you're doing these, please don't forget to show your steps. Okay, you do not need to number them, but you do need to show them. If it helps you to number them, by all means, do that. But what you may not do is just skip and choose what steps you want to do. I am telling you, I require you to do 5 steps every time you're doing a problem like this. All right, guys, I think that wraps it up. I hope it was helpful for you. If you have questions, please, feel free to send me a remind text, whatever you need to do. These problems are not that bad. I think you guys are going to be okay. I hope you have a good day. And as always, be proud to be a Jet.